Welcome friends in the lecture series on thermodynamics. From this lecture, we are going to start new module of this subject, which is temperature and its measurement. So in this lecture, we are going to discuss Zeroth Law of Thermodynamics, which is the basis of temperature measurement. Before going to start the Zeroth Law, let's understand the meaning of thermal equilibrium. Consider a metal rod with temperature gradient. So the one end of this rod is at 50 degrees centigrade and the another is at 150 degrees centigrade. We know due to this temperature gradient, the heat will be transferred from high temperature to low temperature. So heat will flow from high temperature to low temperature until rod reach to a uniform temperature. Take another example. Consider two bodies A and B which are physically in contact. If the temperature of body A is 90 degrees centigrade and the temperature of body B is 30 degrees centigrade, we can say heat will be transferred from body A to body B. Now cover both the body with the adiabatic wall so that body cannot be interact with surrounding. So body become isolated due to this adiabatic wall which do not allow any heat transfer. So we know heat will be transferred from body A to body B, and after some time the temperature of both the bodies become equal and there will be no heat transfer between these two bodies. Then only we can say these two bodies are in thermal equilibrium. It means the body A and B are in thermal equilibrium and there is no heat transfer from A to B or B to A. Now let's start the Zeroth Law of Thermodynamics. The Zeroth Law of Thermodynamics states that if two bodies are in thermal equilibrium with third body, then they are also in thermal equilibrium with each other. So let me explain this. Consider two body B and C, which are in thermal equilibrium separately with body A. So these two bodies are in thermal equilibrium with third body A. Since the body B and A are in thermal equilibrium, so we can say there is no heat transfer between body B and body A. Similarly, the body C is also in thermal equilibrium with body A. So there will also no heat transfer between body A and C. So according to the Zeroth Law of Thermodynamics, when two bodies are in thermal equilibrium with third body, then those two bodies are also in thermal equilibrium. It means there is no heat transfer between body B and C. We can also represent the statement of Zeroth Law like if body B and A are in thermal equilibrium and body C and A are in thermal equilibrium, so according to the Zeroth Law of Thermodynamics, body B and C are also in thermal equilibrium. So we can say if there is no heat transfer between body B and A and no heat transfer between body C and A, then according to the Zeroth Law of Thermodynamics, there will be no heat transfer between body B and C. So how can a obvious statement can be a Zeroth Law of Thermodynamics? So let me explain with the help of another example. There are three friends A, B and C. C has to pay $500 to B. However, there is no due between A and B. Similarly, A and C also nothing to pay each other. So can we say there is no due between B and C? As we already know, C has to pay $500 to B. So it means it is not too simple. When we are saying that there is no heat transfer between body B and A, it means both bodies has same temperature reading. It means the temperature of B is equal to temperature of A. Similarly, if there is no heat transfer between C and A, it means the temperature of C is equal to temperature of A. Now we can say the temperature of B is equal to temperature of C. So the temperature of body B and temperature of body C are equal. It means both are in thermal equilibrium and there will be no heat transfer between them. By replacing the third body with a thermometer, the Zeroth Law of Thermodynamics can be restated as two bodies are in thermal equilibrium if both have the same temperature reading even if they are not in physical contact. So let me explain this. Consider an isolated system in which body B and C are placed. These two bodies are separated with the help of adiabatic wall. It means there will be no heat transfer between body B and C. Now consider body third. If body A is in contact with B through a diathermic wall. So diathermic wall is a wall which allows the heat transfer. So heat can be transferred from A to B, or heat can be also be transferred from B to A. So after some time, body A and B come into thermal equilibrium. It means the temperature of body A equals to the temperature of body B. Now if we allow body A to contact B through a diathermic wall, and if there is no heat transfer between body A and C, it means the temperature of C is equal to temperature of A, and we know the temperature of A is already equal to temperature of B. It means the temperature B and temperature C are equal. So they must be in thermal equilibrium, even they are not in physical contact. So our body A acts as a thermometer. So first it measures the temperature of B, and we have the temperature reading. And if we measure the temperature C, and if we got the same reading, it means the temperature of B and temperature of C are equal. It means they are in thermal equilibrium, even they are not in physical contact. So before the zeroth law of thermodynamics, the measurement of temperature is not possible. It is only zeroth law which enables us to define temperature. The zeroth law first formulated and labeled by R.H. Fowler in 1931. It is recognized more than half a century after the formulation of first and the second law of thermodynamics. Since the zeroth law of thermodynamics precedes the first law and the second law of thermodynamics in the logical presentation of thermodynamics, therefore this law is called zeroth law of thermodynamics. So it is discovered after the first law and second law, but it is always put before first law and second law. And this law is really the basis of temperature measurement. So in the next lecture, we will discuss what is temperature and how it is measured. So this is all for this lecture. Thank you.